So, good morning, everybody. Welcome to the next presentation. So we will talk about a critical point: electrical systems. Electrical systems have a short lifetime, too short for nuclear business, and so we want to tell you a little bit how we keep such systems alive over decades, not just years. We do it for a really long time. We want to talk about our products, of course, why we have this experience. We discuss the problem, what is the reason why we do this presentation. We discuss about our technical approach, how we design equipment. We discuss a bit about experience, case studies, so how did we solve these problems in real life? And in the end, of course, outcome, conclusions, discussion, questions. Questions will be in the lobby over here. And that's it. So who are we? We are the company Wälischmiller Engineering. We are a German company. We do remote handling since 70 years. And part of this company is me, Hubert Hafen. I'm a mechanical engineer. I'm working on electric-driven manipulators since 35 years now. So I got some experience. I got some experience with the typical problems of our customers because they call me. And so that's what we are. We do mainly nuclear equipment, remote handling for nuclear applications. We do mechanical telemanipulators, we do robotic systems, everything in between from the simple tongs to the fully robotic systems. So our standard equipment, which we also have on our booth to test, to have a feeling how it works, are our A100 and A200 manipulators. They are operated purely mechanical, but as we need an electrical offset, we have electric components, we have electric motors, we have a simple power supply, and we have a simple control system. So it's also electric, even if everybody knows it's a mechanical manipulator. Then we have, of course, fully electric driven power manipulators. It's our A1000 series, and they are equipped with electric motors for every single motion, sometimes two motors for one motion for redundancy. These need power supply, these need a PLC to control the interlocks and all these things, give the operator information back and forward. And quite often we have camera systems on board. So there is a lot of electric on it. And in the end, we have the robotic system, the Talbot, which is a specially designed robot for nuclear environment. So it's a manipulator that has all robotic functions. So it is designed as a manipulator. That's the difference between our Talbot and an industrial robot. Industrial robots are designed to do things which are programmed and just repeat these operations all day. These machines, they have electric motors and need, of course, to do robotic functions. They have position feedback on different ways. Mostly it's a resolver on the motor, and to do this, of course, we need a power supply, we need a PC control system because it's more intelligent, because we have to calculate positions from rotary motions to linear coordinate systems. We have camera systems mostly on board. We have a haptic input device, which is also quite a lot of electric on it, and tons of options. There are so many options on it. It's usually, yeah, everything is possible on these. Our control systems, the interface to the operator, we have from the simple switch and lever panel over joysticks and the joy arm, which is a 6-axis force feedback joystick where you can operate with one hand 6 motions with force feedback. And in the end, which is the most intuitive one, is our Talbot input device. It's a master arm, which is similar from the kinematics than the slave arm. So what is it what customers need? Why do they call me and why do they give me the gray hair? It's a simple thing. They say, oh, some pieces, some PLC, some I/O modules are no more available. What can we do? It's running out of supply chain. Very often suppliers disappear or they just change again and again their model, and it's not compatible anymore. And so they call me and say, hey, what can we do? My machine is old and we need to work. Sometimes it's just a simple thing, which means incompatibility of the system or interfaces with cybersecurity standards. Yeah, standards change faster than our equipment. So whenever you touch a system, you have to do it according to the standards which are at the moment valid, and that's difficult. So, or sometimes they just have increased number of failures. The electronic parts, simple components dry out or they age, just age. And these electronic parts then make headaches. And so they call us and say, hey, I got this problem, what can I do? And sometimes we are able to supply special spare parts, and sometimes we have to replace a little bit more. And also important, generations change. So many of the people retire at this time, and those who grew up with Windows 98 and these, let's call them historic things, they go into retirement now, and nobody is able to keep the system alive. They don't have the experience, they don't have the knowledge about this historic technology. And so the question is, how can I make the system modern? How can I make it to the young people for they accept it and for they can maintain it? And now we talk about the technical approach, how we do this. And so the important thing, the basic, is to be prepared. So since decades, we know that our equipment has lifetimes. Sometimes it's written in the specification. They ask us for a lifetime of an electric equipment for 20, 30 years. And so when we sign the contract, we have to keep it alive for the next 20, 30 years. And quite often they really do it, and even longer. So one of my first projects was in Japan, and they asked me, will you be able to supply me spare parts for 20 years? And I said, yes, I promise. And that was 30 years ago, and we still do. And it's still alive, the machine is still running. It's getting more and more difficult to get the simple little spare parts from electronic parts like resolver software and electronic, which gives out the position because they had special wishes and make it difficult. So what is important? So we have a modular architecture on our system that we can replace units. So it's not just the mechanical where we, for example, on the A1000 on the power manipulator, where we can replace very simple the arm elements. It's also on the control system, on electric parts. You have to create good interfaces, and that's the next, the interface management. So you have to have interfaces which you are able to control over the next decades. It's not so easy, so you have to be prepared. And a very important thing is the long-term support strategy. So we don't just supply equipment, we also also do the service. So we promise whenever you call us, we will be there in a short time. So that's part of our relationship to our customers. And so we know that this will happen. We know that they will call us, and that's important for everybody in the team knows this. So what we did, well, that's something historical. One of our first robots and the first power manipulators and historic user interface, a switch and lever panel. They still look similar, but at that time it was cut out of black metal, so it was an aluminium, and we cut it and we stick it onto the board. Nowadays it's just laser written on it. It's simpler, and you see for example, the monitors. They have been really historic, but that was 80s. In the 90s, it was getting more modern, even having modern project managers already. And so still, at that time, I didn't have that much spare part problem, so the hair was still dark. And so, but there you see also on the screens, the monitors of the video systems, it was still, from nowadays, historic. But we already had force feedback telemanipulators, force feedback telbots running with on the system there. They even started having radiation resistant 3D viewing systems, which was not really a help. It was headaching, but it was 3D. So such things have been, and we still keep these things alive. Now in the 20s, it looks a little bit different. So, but still the user interface is somehow similar. So these people who buy a new equipment, who replace it, they get similar interfaces. So the operators, they are happy to do it in a way similar, but now it's more colored and it's having a little touch screen on it and all these things. We make it modern, but still looking a little bit old-fashioned to keep the relationship to the operators. So here we see also typical user interfaces. You have touch screens. You can do all the adjustments on a touch screen, and we have the haptic input device where you can operate with two arms. So this system is running in Sweden at the European Spallation Source, and one similar system is in Oak Ridge on the Spallation Neutron Source. And for fusion maintenance, they will use this system as well. So typical hardware changed. So we have nowadays, we have Ethernet, we have field bus and all these electronic parts which everybody knows. It's critical. It's from spare parts, it's somehow critical, but therefore You have to choose the right supplier. You have to choose the right thing. So now to some projects we did on spare part stuff. So we did a complete modernization of a aging power manipulator. So the mechanical structure was still good because it's metal, it's not that aging, but cables under radiation and other influences get old, they start losing their isolation. And so they decided we want to have new cabling, we want to have the PLC, so it was still Siemens S5, which is difficult to get spare parts or impossible nowadays. So we had to increase this, and we did new operating panels, program, and also documentation. Documentation in the 80s, 90s was still paper. It was handwritten papers, and nowadays you want to have it on a PDF file where you just put your finger on the link and you switch from, especially on electric documentation. That's very important to have a modern documentation. On another project, we just had a very simple thing, which was a replacement of a DC driver. So they have been in the past very reliable and good equipment, but at the time it was on a chassis, and now we have just these rack-mounted equipment. And so we modernized these things. So we had the modern controller on a rack, on a chassis version. So it's mainly a mechanical interface, but it's an electronic part. Yeah. So another thing is cables. Cables of the 80s, 90s have been from a different material. Nowadays, some components of the plastic or rubber is no more available or no more allowed to use, and so the behavior of cables change. So they get more stiff. It's more difficult to keep them that flexible, and they have to be halogen free. All these points have to be taken into account. So when you want to replace a cable, you can't just buy it in a shop, and it doesn't have the same behavior. And so you sometimes have to modify the cable reeling system and all these things. Or another project was just the software. The customer was asking to have for the Talbot system, which was supplied about 10 years ago. They said, okay, we have seen you got much more comfortable software nowadays. The user interface is much nicer, more colored, it's such a lot of additional features. And they said, okay, we would like to have it. And we said, oh, yes, we can. But then we start discussing about the new generation CPU and motor controller interfaces and more modern touch panel and other functions as well. A challenge was, of course, in this case, when you start modifying software, you need approval, because in the end, you did a test of the system with the old software, and so now you have to do all this approval stuff again. They had a very customized cabinet, and so there was no space. It was very compact, and it was under the table. It wasn't standing in a switchboard room. It was just under the operator's table, and everything was completely narrow, filled up. So there was a lot of things to do. Then we did new communication interfaces, more modern, and of course, which is again a headache sometimes, a completely new manual, operator's manual, because operators need paperwork, they need instructions, they need the possibility to look if they have a question, how do I do it, and all these things. So that's what we did on it, and all the documentation. Now we come to a short conclusion. So the question is always, why can we do this? Why is my hair gray and still some hair on my head? And because we would say we do some homework, we are prepared, we know this since decades, we work on these equipments. So for example, on the power manipulator, we have a simple system, which means DC drives, DC motors, which give me less headache because DC systems are old-fashioned. Since a long time, everybody says, why do you use DC? That's old-fashioned. But on DC motors, the development cycles of products are much longer than on a modern AC servo drive. AC servo motors, they change every few years completely. You don't get the old models, and it's more difficult. On DC equipment, it's already like an old vintage car. They give you the support to keep these things alive, because very often the DC is system in important systems, and so there it is for us easier to get support from suppliers as well, and the systems are really long term. Our most important thing is the suppliers. Of course, whenever you start a project, you have to think about components, and the important thing for spare part for these things is not using the cheapest supplier. That would be the worst case. And also don't use the best. So design engineers always come, hey, there is something much better. I found something that has a better performance. Yes, but where will this system be in 5 years, in 10 years? Will we still be able to support it? We need robustness, and therefore not the cheapest and not the best as well. So it has to be robust. So that would be for me the best, but not the theoretical performance, which would be nice and bright to use. Intelligent design means everybody in the company needs to know where this equipment goes. So our design engineers quite often are also on site to have discussions with customers, and so they know what it means if you go in a hot cell. They know what it means if you get radiated. Nobody wants to do this, and so they know it has to be prepared for keeping it alive. It has to be prepared for, in any case, you can replace components in a short time. Sometimes it's required to have remote exchangeability of components, but that's not always the case. That's more sometimes, but always in a short time, because whenever you have to go in, you want to go out as soon as possible. What's also important, documentation. So for all our equipment we supplied in the last 60, 70 years, we still have full documentation in-house. So it's we got downstairs an archive which is it's not so easy to find the right paper, because it was over the generations, everybody did it in a different style, but we have all this stuff available, and that's sometimes really helpful if you get a call, an emergency call, system is not running, and you have to go down, and after some hours you find the right paper. And also the most important part, I won't solve the problem. I'm the contact. So I need specialists, and so we have these specialists in-house. So we do the software, the control software in-house. So we can discuss with these people. We have the electric design in-house. So they do the design, and they, even if you have to modify something, they are available. They are on a short notice, and I can just walk one step down and discuss with the people, and that's really helpful to have all these electrical, software, and mechanical engineers in-house. That's one of our big strengths. And so we are through. We tried to explain how it is possible to keep systems alive for decades. We do this. We sometimes have headaches, and it's not so easy, but we understand our customers. We know about this, and from the beginning of a project, we know it will come. One day they will ask me, and so sometimes one joke was we asked them to buy a spare computer. It was Windows 98, and they said, no, we don't need a spare computer. And I said, please. They said, no. Some years later, they had a hard disk crash. The hard disk was completely gone. It was Windows 98. It was no more available exactly, so we had to modify the complete infrastructure of the control, and they paid. At that time, it was about 10,000 euros, which is not that much, but it could have been done for 1,000. And so that's always a question. Please, it's a story between customer and supplier. What should be on spare part on site? What do we have on in our facility? What do we have on spare parts? And that's the difficult thing. To keep it alive, we need both. We need the customer and we need the supplier. And that's it. So, and if you have detailed questions, come to our booth, or we can discuss here. Thank you very much.